It's Oliver Choi from Slalom. In this video, I am going to basically get into the technical deep dive on the AWS Black Belt Capstone project on NLP, natural language processing. Please see the overview video for the overall architecture and also the technologies being used and overall design. Here in this video, I will be going through the implementations one by one. So as you can see, I have already signed into the AWS console, and the first service that I'm going to cover is Amazon Comprehend. If I go to analysis jobs, you will see that I have, these are the jobs that I have created before, and as I have mentioned in the overview video, there were two different types of the analysis that I have executed before, one for topic modeling, and then the other one is the sentiment analysis. To create a job, and there are multiple ways of doing it. One is by simply doing this in the console, setting up by creating a job, give it a name, and then there are various built-in analysis type that you can select. And in my case, I actually did not do create the analysis job through the console. I'll be showing in the next screen in SageMaker on how to use the API to do just that. But there are other parameters that you can supply to while creating the job, which I'll be covering those in details as well in SageMaker, especially when it comes to specifying the location as well as whether there's any security parameters such as the encryption key that's being used for the data. And again, at a high level, this is how you create a job. And going back to the jobs that I have created before, here are the job results, and you can dive into each of them to actually go to the S3 location and download the data. Right. Within the data, depending on the detection type, you would have different type of files that are incorporated into this output file. For I believe not the sentiment analysis, but for the topic modeling, you will get a CSV file basically capturing the different topics that are able to identify by comprehend. Again, is in the CSV format. So let's go to SageMaker then, as I have a instance that I created before. If I go to the Jupyter lab, which by the way, all of these are on my GitHub, all of the files, as well as all the implementations that I'm going to cover for the other services, including Glue, the crawlers, no, not the crawler setup, but the Glue jobs, and also all the Python scripts. Those will all be available on my GitHub repo. So within the Jupyter lab, if I go to this comprehend notebook here, really quick, I'm not going to go through this in super details, but essentially I am calling the right API, specifying the right the bucket location, and this is commented out by now, but previously I was basically downloading the fast.ai dataset and put it into the S3 bucket, and from the bucket then just for the preparation of the comprehend job, I have downloaded to a to this local disk right here for this instance under the NLP data folder. As you can see, there's data inside this folder. This is the this file right here, the Amazon reviews polarity CSV was the file that was downloaded from fast.ai. And then let's go back to this folder, and as I scroll down, there's some analysis that you obviously can run. In my case, I used pandas for most of the analysis. This shows you that there's 3.6 million rows, meaning different reviews inside this CSV file. And the polarity CSV file essentially is split 50-50, meaning 50% of the reviews are positive reviews, and the other half are negative reviews. So there's some documentation here, and using pandas I can also do the query. They're using class 1 being negative and class 2 for positive. So when I query for just the negative reviews, it shows me exactly half of the original data set, which is 1.8 million negative reviews. And just for the purpose of trying out the AI services, in this case Comprehend, since I don't want to supply the entire data set into Comprehend, I just want to do a subset of that. So I do a random sampling of only 100,000 negative reviews from the same CSV file, putting it into this negative subset data frame. As you can see, I have extracted only 100,000 of them, and then I named this negative.csv and basically upload it to S3 so that I can prepare for the comprehend analysis job. So this is the API that I want to kind of focus on. Like I mentioned in the comprehend console, is pretty straightforward by specifying the detection type that you want to do the analysis on, as well as give it a job name and any additional kind of security parameters and good things like that. So essentially, I have a role created which would only give certain access into both you calling comprehend as well as having access to the S3 data. This role was created within the IAM console, and then there are two different type of analysis that I have tried before. One for sentiment analysis, and then the topic modeling. The way to call the API is pretty similar, amongst all the different detection types. Essentially, you just have to call the right method. For sentiment analysis is the comprehend client calling start sentiment detection job, and for topic modeling is start topics detection job. As you can see, I'm supplying where the data is in S3, and then the format of the CSV file, which is basically one review per line. And the input format essentially it's one doc per line, or I think the other option is everything in a single line. So another thing that's available for additional kind of configuration is specifying the number of the topics that you would like for comprehend to generate. So in my case, it's I wanted to be able to generate 20 different topics from the 100,000 negative reviews, and then I give it a job name. As you can see, this matches up with what I have in here. This for topic analysis, and then I also supplied an encryption key which I was able to generate from KMS. Oops. Let me go back to the Jupyter Lab, and once you basically execute this cell right here, it would give you a response of the job, and eventually you can get the output directly from the console, and the output is also saved into S3. So this is already covered by the other overview video. Essentially, I took the result, which I also downloaded from S3 onto the local disk. As you can see under the comprehend folder, under results, I have this topic terms. Like I mentioned, it was a zip file, and when you extract that, you would get a CSV of all the different topics. So the format goes by you would have the 20 different topics. Each topic would have about 10 different terms. So as you can see, topic 0, the first 10 terms are for topic 0, sorted by the weights. The first term under a topic would have the heaviest weight, and so on. Again, since I have specified 20 different topics, as you can see, on the topic you have 0, 1, all the way to 19. And then I just put this into a table format, which you can go back to this notebook here and see the results. All right, so this is comprehend and how I was able to create the analysis shop from SageMaker. And next I am going to talk about the data processing for the custom SageMaker model training, and also use the Athena glue jobs and the glue crawler and good things like that. All right, the second service that I want to cover, now that we're done with the comprehend, is going to lake formation. As you can see here, I have multiple databases set up already, but by going back to the dashboard, I think the dashboard basically gives you a kind of overview of all the different activities that's happening within the data lake, if there's any that you have set up. And if I go to data lake location, I do have this bucket right here, kind of designated for as the data lake, as well as there's an IAM role attached to this, giving really kind of access restriction to the various data within the data lake. So if I go to data permission, as you can see, there's also the roles associated, although I do not have kind of too many roles and users for different accessibility or maybe permission purposes to really showcase the fine-grained capability of data permissioning for AWS lake formation. Otherwise, I would have done that. There's, again, if an organization would have many different roles and users, you can grant specific data permissions to all these different roles. So let's take a look at the databases again. MLBB, which stands for the Machine Learning Black Belt NLP program, is what I want to focus on for this Capstone project. And if I go in here, there's actually nothing, not much of a detail that goes in here. But if I go to tables, these are all the different tables that are able to be generated by the crawler that I've specified in under this right here. Essentially, this goes to the glue console, AWS glue console. From there, you can set up the different crawlers as well as the different jobs. As you can see, there's shortcuts from this lake formation console here to do the data exploration as well as the processing of the data. So with that, why don't we just go to the crawler? In this case, again, it would point you to AWS Glue. So I have only 2 crawlers that are set up. When you go into a crawler, you can actually specify it to be as generic as you want by specifying, I guess, the location of the data that you want to crawl. So in my case, I have specified a very specific path. It depends on when I have the CSV file ready, and which CSV I wanted to be able to register a new table for. That's why I'm specifying specific paths. But it's also possible to set up a generic path where, let's say, everything under data slash. You can just leave it at that, and the AWS crawler would essentially just depending on the schedule, crawl everything within that particular folder. I'm not going to change this. I just want to show the way that the crawler is being set up. So let me go back here. Essentially what happens is, I close my here, is once you have the crawler set up, and when it's in ready state, you can always just run, and it will take in most cases, as you can see, I do have quite a bit of data. The negative reviews data from Fast.ai actually is in the gigabyte range, 1.5 gigabyte to start with. And to process all of the data, although it's in most cases I only deal with maybe half of that data, which is only the negative reviews. It's still a good size, close to 800 megabytes, taking less than a minute to crawl all of that, which is pretty amazing. And once you have run the crawler, and again, if you look at the database as well as the prefix that I specify, it would take the file name or the path that you're in and create a new table using the newly found data. So if I go to table, that's why you see there's a bunch of tables being created, and a lot of most of them are prepended with this MLBB Amazon reviews. And the reason why I have different tables is as I process data further and further, I would want a different table just to capture the the different process stage, just to show the iterations that I have done. So starting with the all reviews, and then just doing the negative only, and eventually process and combine. Combine meaning since there's two columns within the original data, one is title, one is the review, I want to combine both of them. And then eventually I also, because of the multiple iterations that I had, I also date the table and the file names. So once you have the tables kind of catalog and registered here, in order to look at the actual data, you can go to Athena. So in Athena, let me just refresh this really quick. You can select the database that you want to look at. In this case, I want MLBB NLP, and here are all the different tables that's available from or maybe identified by the Glue console, right? And as an example, I can probably preview the data for this right here. As you can see, there's the review data, and I'm querying this table process combined, meaning a lot of the processing has happened already. Lowercase everything, removing the punctuations, and also combine a column of the text and also review, and I'm specifying only 10 to return. So I can definitely do 100 instead, and this will show me the data, right? This is a quick way for a data scientist to come in here and just look at the overall results and see if there's anything kind of catchy for them to do some cleansing on. Again, that is one way. And as I iterate further and further, there is also, I think I can start with maybe, let's try this one right here. Okay, so for the case of like CSV being parsed, what I realize is that the CSV is able to be parsed by the crawler, but it would actually split it into multiple so-called partitions. The partitions information actually would not be queryable by Athena. You have to do yet another crawling on the partitions themselves in order to generate the table that is can be queried. So let's also try this one right here. So this one, as you can see, is negative only and no label, meaning again, in the original data set, there are essentially three columns. One is the label for negative or the positive review, and then we have the title as well as the review text itself. This one is showing only the negative data, and then there's there's no label, but then there's the unique ID being generated for each of the row. Let's try this one right here. this one here has just slightly over 1.8 million reviews. And the reason why there's actually 13 additional is because of the partitions. When a CSV is being partitioned from the original data set into multiple partitions, and we can actually see from S3 as well. So that's a good segue. We can go into S3. And I am going to go to this bucket right here. There is let me select just one of the folders that we have a partitions on. So these files, as you can see, they're being kind of distributed into multiple parts. Are the partitions, right, from the original CSV into different partitions. And for each of the partition, it would automatically add a row of the column header. So when you recombine all of these into a table, that's why for the Athena query that I was showing, it tells me that there's probably 13 partitions for the negative reviews, and that's why there's basically 13 additional rows for the overall table. So again, this is one of the quick ways to leverage the AWS Glue crawler to crawl the CSVs into partitions and then register different tables for you to do more analysis on. And you can also put a lot of these queries into QuickSight for visualization purposes. So let's go over to QuickSight. Now, QuickSight automatically points to a different region, and it's not like the rest of the AWS services where the region selected would stick. So let's go back to Oregon. And I would like to bring up one of the dashboard that I have set up before. Using the different widgets from QuickSight, you can quickly visualize what you have in the tables that are being crawled by AWS Glue crawlers. So just like the iterations that I have mentioned before, from one stage to another from the original review set, I want to navigate down to just the negative data set, and then from there do further analysis so that I can find out if there is any additional cleansing that I should do before the model training. So that's why I have multiple tabs set up here in QuickSight. Again, just to kind of explore the different widgets that we have. As you can see under all Amazon reviews, this is again the total set of 3.6 million reviews. Exactly half of it would be negative and the other half being positive. And then the word cloud does not work as well as the Python word cloud package that I have played with. I think in order for the word cloud to be showing the right results, the data essentially will have to be broken down into individual columns for each of the words. So that didn't work. But a quick insight for me is that just looking at the title, we see that a lot of the titles actually started with all these characters here, right? A bunch of Z's. And with this insight, if a data scientist wants to cleanse the data further by really removing these kind of meaningless words, they can do so. And by again, just looking at the visualization, looking at the widgets here, that gives you a really high level capture of what's going on within the data, and then try to drive some cleansing strategy of these widgets. Moving on to the analysis tab, and actually this one might take a while to generate. Let's wait for a second, and you can already see that these are kind of sorted by the words, most common words. This widget is for the sum of the label and the count of the review by review. So as you can see, there's label versus review, and if I look at the actually this is wrong. It's actually the common word between the title and the review text itself. So it tells you for this particular instance, the word unfortunately was found in over 2,000 titles and found in close to 2,000 reviews. And then there's one, this one is very common. The word well appears more than 8,000 times in the title, and more than 6,000 times in the reviews. Again, trying to use a lot of the different widgets available in the quick site for data scientists to come up with additional data processing strategy. Moving on to the negative reviews only. This number here probably is wrong. It could be a combination of by now, because I have generated the negative reviews data set multiple times. This is very close to 3 times the negative reviews. That's what I'm suspecting. And then what's more insightful and information would be these 2 widgets, but it's taking the time to query against the data right now. It's the distribution of the title length as well as the review length. It will tell me maybe if there's any outliers when it comes to the length of the review, so that if necessary I can remove those outliers before getting into the model training piece. So maybe we can come back to this. Let's go to negative analysis first. This one is faster in looking up the maximum length of the review, as well as the maximum length of the title. As you can see, there's also length 0, meaning there's data that should be cleaned up, or maybe the rows that should be removed before getting into model training. And see if this is being rendered now. Okay, let me pause for a minute, and the widget is still trying to render. I think I'll just go ahead and skip this and move on to another service implementation. So we covered comprehend, Athena, QuickSight so far. We also briefly touched on link formation. Let's go to, let me go ahead and close. Actually, I'll just leave this running in the background. And let's try to go to AWS Glue. Alrighty, we touched on this earlier for the crawl-up piece. What I want to focus on would be both the Glue Studio as well as the job implementation itself. The Glue Studio is pretty powerful. If you go to create and manage jobs, there's multiple jobs that I have here. The reason why I have multiple jobs is it requires different stages of the processing, and they can be kind of chained together. So when you get the original data set, which is a CSV file, you want to be able to parse it and split it into multiple partitions, and then from the partitions you want to do further processing, such as cleaning up the data, like filtering down to a specific label, and then maybe do the combination of the different columns. So let's start with maybe the parse GZ right here, which is the original zip file containing all of the data coming from fast.ai. But in this case, I have dumped that file, again, is the GZ file, into a S3 bucket. So as you can see, this is super intuitive in the studio to set up the process, or you can look at this as like pipelines. So I'm specifying which table that I have, was able to crawl from the crawler. Moving on to applying the mapping. Essentially, I want to make sure that these are the different columns that it's able to identify from that table. Again, as I mentioned before, there are three different fields available across all of the reviews. The label, it's either a 1 or 2 for a negative or a positive review. The title itself and the review column. And I want to map it to the right type. Right? Here you can, if necessary, I haven't really done it in this step yet, is to drop certain column that's not needed, right? But again, I have not applied that. And then after the mapping, it would basically spit out the same column for the next step. So what this job does again is to parse that table and then spit it out into a different location. So again, this is starting from the original data set. I want all of the reviews to be in a table and in a CSV format. So this is the first job. You can essentially just click on run, and it will process that for you automatically. And going back to jobs, let's now look at I do not think it's the Python processing, but let's try the negative only drop label. Yes. So for this one, now that we have all of the reviews dumped into this table, again, this is usually a crawler glue job type of scenario where it's very cyclic. You will need the glue crawler to be able to crawl things into a table. You do additional processing, and then the processing output usually would be in could be a partition or CSV format, meaning you will need the crawler again to parse all of that data into a different table. So for this particular job, what it does is to pick up what we have done in the parse GC table before. Now that all of that review is stored in the all reviews table, and you can see that we specified label, title, review for those three columns before, and now I want to apply a mapping. The mapping is similar to the other one, but this is coming from a partition rather than the GC format itself. And here's a built-in step for you to do filtering. So for filtering, I want to be able to, from all of the data, 3.6 million rows, I want to select only the negative reviews, meaning I query for label equal 1. So after that, you would have, I would just want to, spit out the same columns again, but in this case, I want to drop the label because, by this point, the 1.8 million negative reviews are all label equal 1, and I do not need to do any additional filtering based on the label column, so I'm dropping it at this point. And then I put all of the data into a S3 location where I say this is a negative only, and also drop the label, and then I put in the date. So the output of this essentially is a CSV of 1.8 million reviews with only 2 columns left, the title and the review column. And so with that, I think at this point we have the data that is ready for more processing, but the additional processing unfortunately cannot really be supported by the Glue Studio using the drag and drop capability. So let me go back to Glue, and instead of looking at the Glue Studio, I want to look at jobs. So there is a Python processing job that I have created with a Python script. So we can look at the script itself. What this one does here is to well, we first start with like downloading the partitions. Again, the 1.8 million reviews are stored in multiple partitions. I want to be able to download that and then start the data processing. So downloading the partition and then put it into pandas data frame. And then from there, since we have the title as well as the review in two separate columns, I want to be able to combine them into a single column. So I come up with a third column called process as a combination again for title and review. And then since we now have both information in a single column, I can go ahead and drop the title and review. That's why you see in the data frame I'm dropping those two columns, leaving only the process column, which is again a combination of the title and review. And then I have a step for removing the punctuations. In this case is removing any characters that's captured in the bracket here. That's regex. And then after removing the punctuations across the entire table, 1.8 million rows, I want to lowercase everything, right? Here's a lambda function for lowercase the entire text in the process column, and I just basically put it back into the process column. And eventually, I want to spit out this, no more punctuations and everything lowercase data into a CSV file. So the generated CSV file is negative only pre-processed with the timestamp, and then I put the CSV file into S3. So going back to S3 really quick. And if I go to data, I believe it was under, so there's negative only pre-process the timestamp. Okay, all right. So those are the capabilities from AWS Glue. Again, there's the easy drag and drop type of scenario available in the Glue Studio, as well as a custom script. In this case, it's a Python script for the job specification to do the processing. And once you have done all of that, you have data that can easily be read by, of course, SageMaker, since everything is stored in S3 at this point, to do maybe additional processing before stepping into the model training. So let's cover SageMaker as our last service that's implemented in this project. SageMaker, we have talked about the comprehend notebook before, so let me go ahead and close that. Because of the different iterations and experiments that I have ran, that's why there's multiple notebooks being provided. But I started with the LDA trial before, where again, all of these are available on my GitHub repository. A lot of these involve basically loading the data into the pandas data frame, and then do some additional analysis. As you can see, this is before I put the pre-processing pipeline into Glue. just by kind of experimenting, all of the different Python steps to do that pre-processing before I eventually migrate those steps into Glue. So that's what I've tried. Another nice thing about doing all these in a SageMaker Lookbook is there's additional Python libraries that you can leverage to get the work clouds and things like that running, and also try out the different strategies on both tokenizing and also lemmatizing the data before the actual training. So as you can see here, this might be early on. I haven't really implemented the lemmatization steps yet, but already experimenting with the scikit-learn library on the CAN vectorizer before the data training. So with that, let's go ahead and go to this LDA with the timestamp notebook here. This is the final implementation of the model training. But before that, what I would like to say is that I have shown the Glue capability before to do some pre-processing. But before getting into pre-processing, there's the tokenization and also lemmatization need on the data before you can actually call the LDA algorithm to do the training or come up with the topics. So in this separate notebook, what I was able to achieve is to get that pre-processed data. Again, it was in a CSV format that's stored in S3, 1.8 million with an additional row for the column headers. As you can see, is processed, is showing at the top row, and I wanted to be able to drop that. Also from QuickSight, I've shown earlier that there are empty rows, rows without either the title or the review that I want to drop. So there's additional cleanup steps here where I want to drop, let's say, rows that does not have anything in it. So drop all the non-numbered rows, right? And process further by, let's see, this one here is after Glue, I want to be able to remove all the quotes. So there's the word like wouldn't, such as here the apostrophe. I want to be able to drop that before the data, the model training. And at this point, through the QuickSight, I was also able to identify at least a number of reviews that were written in Spanish. There are definitely some toolkits and also library available in Python to maybe remove non-English words, or in this case non-English reviews, but those are usually pretty involved. So a quick way to do that is to just basically drop all the non-ASCII characters. And this is a function that I have here just to drop the other non-ASCII characters. And so I go through all of the all the processed review, and apply this function here, and eventually drop at least 5,000 reviews that were written in this case, non-ASCII characters. Again, a lot of them were in Spanish. And finally, there's the stop words package that's available in the Natural Language Toolkit Python library. And I did not print out all the stop words here, but I have covered this in the overview video, where words like if, he, she, and, or, those I would say words that does not provide too much of a meaning. I want to be able to drop all of that from the table. So using this package, I can simply, let's see, right here through this stop. Let's see, stop words, tokenizing. Where did it go? Okay, let me look for that for a second. There is this the tokenization step. Drop tokenize stop words. I don't know if no, this is not it. Oh, there you go. There, this line right here. If the words is in the stop word list, and if it's in the review, you basically drop that word, right? So and then in the same kind of function, I want to be able to tokenize that, so that the sentence will be split into basically individual words. And finally, with that, here's an output. So originally is this, which I have also displayed in the overview video and the PowerPoint presentation. This is the tokenized version, and then we apply lemmatization on that, and this actually took a long time. Can probably speed that up by not looking for all four different types of stemmings. Right now I'm doing nouns, adjectives, verbs, and so on for all of the data. Can probably skip some of this, but at the end of the lemmatization process, it's able to from the original line of this right here, ugly, this ring is so ugly, so on and so on. After lemmatization, it's able to get to just this more meaningful words here. That's definitely more relevant to the negative review. And once we have processed the same thing for the close to 1.8 million roles, I want to save a copy so that the new CSV can be directly just feed into the model training process. And since the model training process, of course, takes a wait a second, let me see. There you go. I have applied the same in this notebook, but the training process actually is captured in this LDA notebook instead. So at the beginning of the LDA notebook, it's downloading. It downloads that lemmatized reviews, which is an output from this tokenization lemmatization Python notebook into S3, and I just basically download that into the NLP data folder, and just read from that using the pandas data frame. So you can see lemmatized review with the date. Same number of the reviews as I've seen before, and then putting them into a format that can be feed into the topic modeling training by using the count factorizer. I also kind of do some exploration on the this TF-IDF factors instead of using the bag of words. But at the end of the multiple trainings, I felt like the count factors is actually more effective than the other one. So at this point, since we have the data in factorized format, and let me go back to here. The gist of the training is I parameters set up just so I can change this easily. The number of the topics that I want to be able to generate is 25. Setting up the instance type, and also I can easily turn on the spot instances if necessary, and all this would feed into this API call of the estimator using the LDA container that is provided by AWS, of course, and just call it fit with the training data. Again, is the data that's coming from this file right here, an lemmatized review CSV file. And after all of the training, which took again less than 30 minutes, you would get the output, right? And the training job completed, it took it's only a little over 20 minutes. The managed spot training savings 57.9%, which I have also talked about in the overview video as well as the presentation deck. And then eventually I would be able to get the file, extract the model or the results from the file, and put it into a very nice format of all the different topics. So as you can see, the different topics here with the different terms in each of them. It's really kind of comparable to what Comprehend would be providing from the native services standpoint. So then this is exactly the table that I put into the presentation deck. So again, I guess this kind of a implementation deep dive is to show the kind of detailed steps on how to do the notebook, all the pre-processing steps in the AWS Glue console, how the overall processing as well as the data storage and good things like that being captured by the overall lake formation, and also a quick site where you can really visualize the data, give you better insights on if there's a better cleansing strategy. So with that, I will just stop here. Please refer to the overview video just to get a overall understanding of the Capstone project as well as the overall results. All of the detailed scripts and everything here in this folder are actually on my GitHub as well. So feel free to check that out. And thank you for watching this video.